Going to do IGCSE Physics, that is 0625, the year 2026. This video is for you. I want to take you through some of the most important areas that you have to remember as far as that exam is concerned. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. Don't forget to join our Patreon page, where you can be able to access the PDF of this paper that you can be able to see here in this presentation. So we are going to look at what are the main areas that you really need to understand, that you need to remember as far as IGCSE is concerned. After going through different areas in physics, you've come across different terms, different quantities, and because you know physics involves quantities where you do measurements, and then you are going to categorize different quantities in physics as either scalar and vector quantities. So you need to understand what scalar quantities are, what vector quantities are, so that you can be able to answer some of the questions that will be tested in 2026. Now, we are supposed to draw a circle around two other quantities in which the list which are vector quantities. So the first thing that you need to remember is the definition of a vector. What is a vector quantities? Vector. What about them? They have both sides and direction. And we know that if we are representing a vector, we're gonna use what? A straight line to represent a vector like that. And then we shall be able to, we must have an arrow indicating the direction in which that particular vector is oriented to. So when we're talking about scalar quantities, yeah, scalar, they have only size. They have only size. Now, for instance, we can talk of time to 20 minutes. So if we are talking about 20 minutes, you are not looking at in which direction. So we can talk of 4 grams. We are just talking about a quantity. We are not specifying in which particular direction that is happening. So we are supposed to draw circles around two other quantities in the list, which are what? Vector. They have both size and direction. So number one, we shall talk about momentum is one of it. We can talk about acceleration. Acceleration is actually one of the vector quantity because it has velocity. Velocity also has direction. Then now when we are talking about mass, refractive index, energy, density, all these, and power, all these are what we call scalar quantities. Now you're going also to look at the topic motion. Under motion, you are going to analyze different graphs. Yeah. Now the student moves a model car along a bench, and then we are supposed to describe the motion of the car in each of the sections. So we have different sections of this graph which we need to describe. Now something that you need to remember for velocity time graphs, we have area under graph, area under graph, and the area under graph represents this displacement, represents what we call displacement. And then when we talk about gradient, gradient represents what we call acceleration. And if the gradient is steeper, so if we are talking about a velocity time graph here, this line is steeper, so it has what? High gradient, higher gradient. So acceleration is going to be higher in that case. And this one is going to have low acceleration because it has a small gradient or a less steep gradient. Now, moving to description of motion sections. In A, we have a constant acceleration, or we can be able to say uniform acceleration. And the reason as to why we have uniform acceleration here is because whatever we have is basically constant gradient throughout the line, because basically this is a straight line. Then we have section B here, because if you can identify, still this car will be moving at a speed of 3.5 meters per second. It's not at rest, it's not stationary. So that means that this car here is moving at a constant, this is moving at a constant velocity. And at this point here, in this section B, we can say zero acceleration. So in the event you're gonna be asked what's the resultant force, we know that resultant force is usually mass times what? Acceleration. So since the acceleration here is 0, it will mean that the resultant force at B is what? 0 also. In section C, the car is non-uniform deceleration. This is non-uniform deceleration in this particular section. And then we have a very interesting section here. Now this is stationary. This car is not moving, because if you can look at this, the velocity here is basically 0. So basically that's how you're gonna answer questions to do with motion graphs in year 11 when you are going to do your IGCSE. Remember, area under the graph for a velocity time graph represent displacement, gradient represent the acceleration. And if you are given a velocity time graph, when you are told to state what the gradient represent for a distance time graph, it will mean that is a velocity or speed. Let's look. Determine the distance traveled by the model of the car in the first 5 seconds. So the key word here is first 5 seconds. So how are you going to go about that? Yet we can be able to see in the first 5 seconds will end here. So which will mean that we are going to draw a triangle in this particular section here. Yeah. Then we shall work out the area of this part that we have here. We shall work out the area of this triangle that we have at this particular point, because I mentioned that area and a velocity time graph represent what? Displacement. So if you are asked the distance now, the distance, determine the distance, this is the area. So we are going to say distance is going to be equals to what? Area under the graph. And now the formula you are going to use to find the area under the graph is going to depend on the shape of the section that you are finding the distance. Now you can see in this case here, whatever we have is what we call a triangle, and we know area of a triangle is a half base times height. So don't fall into a trap of saying that distance equals to speed times time. Don't fall into that trap, because we are finding now here in this case, we are trying to find motion. We are finding motion using what? A velocity time graph, not just that, anything like that. So we can see the base is going to be the 5 seconds, and the height is going to be 3.5. So we are going to say this is going to be a half times base, which is the base is what? The base we have gotten it to be 5. The height is 3.5. Then now in year 11 you'll be allowed to use your calculator in the physics paper. Yeah, so this is going to be what? 0.5 times times 5 times 3.5, and that is going to translate to 8.75. Our answer is going to be 8.75 meters in that case, because we are not going to write the units for area, because we are saying that distance is equivalent to the area under the graph. So that's the formula that we are just using in order to answer that particular question. All right, so moving on to the next question. A battery provides energy to an electrical car. The electric car has acceleration of this 2.9. The acceleration 2.9. So anytime you'll be given physics questions, remember you'll be in a position to make sure you'll be in a position to identify what's given, and then we're going to see which is the best formula we can be able to use to work out that, calculate the force required. So this kind of question basically is a question whereby we are going to use Newton's second law, which is going to be force is equals to mass times acceleration, right? So in that way we can be able to check. Our case here, we are given the mass and we are given the acceleration, so our work is just to substitute them, which is 1600 kilograms times 2.9. If you work it out, what is it going to give us? 1600 times 2.9. If you work it out, you get 4640. Get 4640 now, because that is a force and that becomes now our resultant force. So this is going to become what? 4640 as our final answer. And don't forget to write units. In that case, if they are not written, is also another marking point. If the units are not written, you are going to lose marks. So these are the key areas that you need to remember whenever you'll be answering physics questions in 2026 IGCSE. A student collects this amount of water, 0.21 kg of water. Calculate the weight. Now, formula for weight. Yeah, so we're going to say weight is equals to mass times acceleration due to gravity, mg. So that means we are going to say 0.21. So something that you're going to check, what kind of value of acceleration are you given? G, is it 10? Are you provided with 10 or are you provided with 9.8? So keep that in mind. And also, whenever you'll be working out these questions, you should be checking whether the unit for mass is it given in kilograms or in grams. So if it's given in kilograms, well and good, you'll have to use it that way. But if it's given in grams, you have to convert the mass into kilogram. So you know, if you have x grams, to convert it to kgs, what you do is that value divided by 1000. So remember that as far as this paper is concerned. So we're going to say this is going to 0.21 times 9.8. If you work it out, you're going to get your final answer, translating to 2.058 as your answer in that part. Which other area or which other concept will you be likely to be tested mostly? In this case, the concept of density. So you should know how to work out questions with density. Remember, density is given by density is equals to what? Is equals to mass over volume. So depending on which units you are going to give your answer, you have to ensure that they are in the correct unit. So in this case, I'm going to get my answer in grams per centimeter cubic. So meaning that my density, my mass should be in grams, and the mass here is given and provided, and then we have the volume at that point. So this is going to be 1260 divided by 150. That's an international crisis. Then let me say 1260 divided by 150. We work it out, we're going to get 8.4. Our answer here becomes 8.4, and that is 8.4. We have to transfer our answer here just to make the examiner happy. So the concept of density, make sure it's fresh in your mind, so that whenever you are going to be asked questions in that particular exam, you will be in a position to answer them. And if you are new to ProfLearn YouTube channel, consider subscribing, so that in time I'll be uploading more tutorials later. When you are going to be doing these exams, you'll be in a position to answer most of the questions. All right, so the mass of the metal object is given in grams. State the mass in kilograms. So the metal we are talking about is this, and already I've mentioned in the previous section. If you are converting mass in grams to kilograms to mass in kilograms, you need to use the value that you are given, just divide it by 1000. So in this case here, we were given 1260 grams. So to convert it to kilograms, we should divide this by 1000. So if you divide this by 1000, you're going to get 0, 1, 2, 3. So we're going to get 1.26 kg as the mass in kilograms. So this is going to be 1.26 kilograms. So basically that's what you do whenever you are trying to convert, or change mass from grams to kilogram. Just take that value that you have there, divide it by 1000. You're good to go. You'll be able to answer and get your marks. Then we have another very, very strong student here who's holding something 50, imagine 50 kgs, sorry, 50 newton using one hand like that. There is a turning effect, right? Turning effect. Pivot is somewhere here, right? All right. Now, the student is doing some physical exercises, and then we are supposed to calculate the moment. So the first thing that we're going to remember here, what's a moment? Moment is going to be defined in year 11. It's going to be defined that moment of force is the turning effect of a force. We are going to say a moment is the turning effect of a force. But how do you get it mathematically? It's force times perpendicular distance. Perpendicular distance from the pivot. So in that case, our pivot is here. That's where the turning effect is. The turning effect here, somewhere here, turning effect. The distance to the pivot from the where the force is held to the pivot, the distance here is 0.9 meters. So we are going to say this is going to be, the force is 50 times 0.9, and if you work it out using your calculator here, you are going to get 50 times 0.9, which is going to be 45. So 45 Newton meter. So this becomes 45 Newton meter. The SI unit for force in this case is going to be Newton meter there. Yeah, so for those guys who are going to do exams in year 11, don't forget to learn about, don't go to that class if you have not learned about a moment. And these are the concepts that you're going to learn. And then we're going to look at the concept of equilibrium. We are going to look at principle of moments, whereby we're going to say principle of moment states that clockwise moment is equals to anti-clockwise moment, which we are going to see in the next question that is here. And the next question says calculate the moment of 5.2. So if we have this force at this end here, this force is going to result to a clockwise moment because it's at this end, so it will be pulling. If this the turning effect, if the pivot is here and the force is pulling at this point, it's going to make it turn like this. So this is going to be a clockwise moment. This P force P is a force that is pulling up, then the object is going to experience anti-clockwise. It's going to experience a clockwise moment. So this one is going to provide clockwise moment in that direction, and then this force that is at this point is going to provide anti-clockwise moment. Yeah, so those are the forces that we have, and we are going to say moment is equal to the sum of anti-clockwise moment. So question A, we are only asked to calculate the moment due to the 5.2. So that's going to be 5.2 times the distance from where 5.2 is acting to the pivot. What's the distance from where 5.2 is acting to the pivot? The distance is 6 centimeters. So 6, and that is going to be, if you can see, this is going to be 5.2 times 6, which is going to translate to 31.2 Newton centimeter, which is approximately 30 Newton centimeter, as expected, because we were supposed to show that moment is that. Then the beam is balanced, calculate B. So meaning clockwise moment is equals to anti-clockwise moment. So basically that's what we are supposed to do. Okay, all right. Stop crying. So let's now do physics. We shall continue doing this physics here. Yeah, shall continue doing physics here. Yeah. So we are going to see how we are going to work out that value of P, whereby we shall be using clockwise moment is equals to anti-clockwise moment. 15 is equals to 3P. Is equals to 2P. So meaning that we shall have our P equals to 7.5. Our P in this case is going to be 7.5 newtons. Yeah, so that's what you are supposed to do. In that case, whenever you are given a question that requires you to work out or use the principle of moments. So as you're going to do your year 11, or you are heading to year 11 2026, you need to be aware that you'll be working out question with a moment and a principle of moment in that particular case. So let's go ahead and also look at another concept that will be key, will be important, will be coming up in year 11. The diagram shows a model of a wind turbine used to demonstrate and use wind energy to generate electricity. So you are going to learn about electrical energy generation, whereby you shall talk about generation of energy using wind, generation of energy using solar, generation of electrical energy. The mass of air passing through the circular area, the mass of air each second is 7.5. Yeah, the kinetic energy of air that passes through the circular area each second is 240 rather. So calculate the speed of air. Calculate the speed of air. We know kinetic energy is equals to a half mv squared. So in this question, you are provided with the kinetic energy, which is here. You are provided with the mass, which is here, and then you are supposed to work out velocity or speed. And in this case, we are going to say 240 is going to be a half times the mass, which is 7.5, times v squared. And if you work it out, you're going to have what? This is going to translate to what? This is going to be v squared is equals to, if I multiply all two by 2, that will be 2 times 240 divided by 7.5. Therefore, v is going to be the square root of whatever we are having here. That is 2 times 240 divided by 7.5. So if you put that in the calculator, you are going to get what? This is going to be 2 square root of 2 times 240 divided by 7.5. If you work it out, you're going to get 8 meters per second. 8 meters per second. So don't forget to write units whenever maybe you are working out questions in physics. In question number 9, the diagram shows the road next to the sea. Describe how the sun on a sunny day, the sun warms the road. Yeah, and the air above the road is heated by the warm road. Describe how this affects the molecules of air. Describe how this affects the molecules of what? Air. So in this case, what we need to put into perspective is the particulate nature of matter and how particles of air behave when temperature increases. And in this case, we are going to say air molecules gains more kinetic energy. So as temperature increases, the kinetic energy of air molecules is going to increase, and then this will result to making the molecules to move apart, making the molecules to move apart. So if we are talking about Brownian particles of air, we know that if you increase the temperature of the surrounding, these particles will have high kinetic energy. So they're gonna vibrate faster and they are going to move apart. So that is how the molecules are going to be affected when this rod is going to warm the air around that, right? Moving on, we are having questions here showing as asking us to draw from each electrical appliance to the correct useful energy. For a torch, what do you want? Whenever you want to use a torch, what are you expecting? Do you expect sound? Do you expect heat? For a torch, what we are looking for is light. So the useful form of energy is light. For a radio, we just need to have a little bit of dance whenever you are listening to a radio, right? So that is going to be sound, because we want sound as the useful form of energy. Whenever it's hot in a room, you need kinetic energy from the fan, so that the wind, the air can blow around you, so that when the air is blowing, you'll be able to enjoy the good condition around that room. Yeah, but we need to remember the law of conservation of energy. Energy cannot be destroyed, created or destroyed, but can only be turned from one form to another. So what happens is that energy can be wasted in the process. For instance, when you're using a torch, instead of having on a light, you'll feel some heat, because some of the electrical energy is converted to heat energy. We have question number 11. We are told that there is a puddles of water. Name the state process which the water disappears. If you have some waters on the floor, after some time you realize that water will disappear, and that's because some water, that water escaped through a process known as what? Evaporation. So in year 11, you need to know how evaporation causes cooling or leads cooling, and also you need to know the differences between evaporation and boiling. So we need to realize that evaporation appears or occurs at every level of temperature. There is no specific temperature for which evaporation should occur. It will occur in all across all temperatures, so long as there are molecules which have more kinetic energy and they get lost to the surrounding. But boiling occurs boiling point, specific temperature. Describe the process causes the puddles to disappear. So after school, the puddles have disappeared. The diagram shows students walking to school. There are puddles of water in the ground. Maybe in the morning, there are some waters on the floor. Then after school, the puddles have disappeared and the ground is dry. What has happened? What magic has happened in that case? This because more energetic molecules escape. More energetic molecules escape. This is because they have what? High kinetic as temperature increases. As temperature increases, the kinetic energy of the air molecules also increase, and the molecules of high kinetic energy are going to escape. A teacher fills a copper can with solid wax and heats the can. She continues heating the wax as melted and stops heating when the wax is what? Boiling. Now, describe the molecular structure. What is the molecular structure for solid wax? We are going to say molecules vibrate in their fixed positions. Molecules vibrate in their fixed position, right? Molecules are regularly arranged. The molecules are regularly arranged and vibrate in their fixed position. But when we are talking about gas, they move randomly. And here we can regularly arranged and closely packed. For solids, they are closely packed. When we talk about moving randomly, much far apart. Yeah, move randomly and they are very much far apart. Do not have finite shape. They don't have the definite shape. They take the shape of what? The container they are in. So so that is what we need to remember as far as the states of matter is concerned. Then we have question number 13, which is also referring to as different states of matter and the process of conversion. When you're going to do your year 11, 20, 26, some of kind of these questions will be asked. Now, the process from solid to liquid is melting. The process from solid to liquid is melting. From liquid to solid is freezing. From gas to solid, from gas to liquid, how do we call it? Condensation, well stated here. And finally, from liquid to gas is evaporation. Now, this is the part that you are going to learn, which is called states of matter. States of matter, whereby you shall be looking at solids, liquid, and what? And gas. The diagram shows horizontal forces acting on a car. Calculate the resultant force. Remember, we are having a force acting backwards and another force acting forward. This force that is acting forward can be a thrust force from the engine, and the backward force could be a force that is emanating from air resistance and friction. So we're going to say resultant force is going to be equals to 1200 minus 900. So if you work out that, you're going to get 300 newtons. So this is the resultant force of 300 newtons. Already it's written here, so we can't repeat doing that. And then we are supposed to state the direction. The direction in this case is to the right, or to the right, yeah, in this case. Then we have question number 16, which says a car takes 12.8 seconds to travel this distance. Calculate the average speed We know average speed is equals to distance over time taken, which is going to be what? Which is going to translate to 200 divided by time is 12.8 seconds. So if we can put that in our calculator, what are we going to have here? 200 divided by 12.8, which is going to be equals to 15.625 meters per second. So this is going to be 15.6 meters per second. Correct to 3 significant figures, basically. That's what we're gonna have in that case. Yeah, so that is the answer to that case. All right, so we have also a question here that says the diagram shows an hacker pulling a string of a bow like that. The hacker, or we call it hatcher or hacker. This is the hatcher or hacker, right? Whichever. Calculate the pressure. We know pressure. We're going to use the concept that pressure is equals to the force over area, which is going to translate to what? 120 Newton divided by the area. The area is given here. So anytime you're going to be given questions, guys, just look at the question and get to see what is the question really saying, and check which is the best formula you are going to apply in that particular question, so that you can be able to work it out. Yeah, the question can be from a very a scenario you really don't understand, but if you read the question and try to figure out which is the formula related to that question, you can be able to get what the answer is. 0.5 centimeter square. But this one now, we cannot proceed until we know what is the area in meter square. So we cannot be able to use this the way it is. I want you to realize that 1 meter square is equals to 100 times what? 100 centimeters. So which means 1 meter square is equivalent to 10,000 centimeter square. So in this case, it will mean that 1 over 10,000 meter square is equals to 1 centimeter square. So meaning, for us to work out this, the only thing that we are expected to do at this point is to say one pressure is going to be equals to 120 newtons divided by 0.5 times 1 over 10,000, so that we can be able to convert whatever measurement that we have here in meters. So if I'm going to put that in a calculator, 120 over 0.5 times 1 over 10,000, that is going to translate to 2,400,000 pascals. Yeah, pascals. So that is basically what we're going to say. So you can be able to write this in standard form times 10 raised to power what? 1, 2, 3, 4, 5, 6 power 6 newton. Oh. Newton per meter square. Newton per meter square. So, but in a question you are asked to give it Newton per centimeter square, in a question you are given to find your answer in Newton per centimeter square, you'll just take 120 divide by 0.5 and you get 240 and you are done at that given point. State whether the pressure on the hand is greater than, the same, or the less pressure the finger holding the string. The other hand is pushing the ball with the same force. This force acts on a larger area. So if you have a larger area, pressure is going to decrease. Yeah. Now we are supposed to state whether the pressure on his hand is greater, same, or less than on the fingers. On the fingers here, we are having a small area, so we are going to have high pressure. Here we are going to have low pressure, so we are going to say that is low pressure, because there is a larger area of contact. And if since pressure is equals to force over area, when you increase the area, pressure decreases. When you increase the area, pressure decreases, because the two are inversely proportional to each other. Now the mass of the beaker is this. Calculate the weight. We know weight is equals to mg, but we have to convert this mass to kilograms, so we divide by 1000, which is going to be 0.4, and that's going to be 0.4 times 9.8. so if you work it out, 0.4 times 9.8, that is going to translate to 3.92 newtons. 3.92 newtons. So basically that's what you're supposed to do in this part, in this area. Here are some statements about energy and energy resources. We have different statements about energy and energy resources. Some statements are correct. Put a tick in the box alongside each of these. Building hydroelectric power station has an impact on environment. That is true, because whenever you are just building power stations or dams, you are going to ensure that you destroy the ecosystem so that you can be able to get the dam installed. Burning fossil fuels produces atmospheric pollution. Wind turbines are turned using gravitational potential energy. This is very wrong. It's kinetic energy. Coal and crude oil are sources of renewable energy resources. These are non-renewable, because this is an non-renewable, because they can be depleted, they can be finished up. So that is why we cannot tick that. So this is correct, this is wrong. A geothermal station is obtained from rock below the ground. The hot rocks, which is going to burn the water, heat the water, and the water is going to be turned to steam, and then the water is going to gush out of the ground from those hot rocks, and that water is going to gush out at a very high speed. And then if they can be able to put turbines at this particular point here, those turbines can be able to rotate, and when the turbine rotate, they rotate the generator, and the generator generates electricity, which is going to be transmitted to some areas far from the geothermal power station. So we can talk of that. That's correct. Yeah, this is not true. All right, so for us to earn the 3 marks, we have to tick 3 boxes. Looking at question number 13, the solar farm convert energy from the source into different useful form of energy. State the energy source and useful form of energy. So this is a solar panel. Yeah. State the energy resource and useful form of energy. Which useful form, of course, we're going to say solar panel. What is the useful form of energy in that case? If you are given such kind of a question, what are you going to say is the useful form of energy? Just waiting to see that in the comment section. Let me see that in the comment section. What is the useful form when a solar cell is used? How can you respond to that? Which useful forms can we talk about in this case? Right, just write in the comment section which is the useful form we are going to talk about here. Just waiting to read a useful form and from the source to the useful form. Yeah, useful form. Just want to read in the comment section. What do you think is going to be the useful form in that case? Yeah, this question 19, yes. What will be the useful form? Just waiting so that I can be able to write in the comments. Read it in the comment section. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. Also, check in the description. There is a link that is going to take you straight to where you can be able to download the PDF that I'm working on here in order for you to be able to write it as you are following this discussion that we are having at this point. So in this case, we are going to say this conversion that is going to take place is going to be light is converted to electrical. Is converted to electrical. Light is being converted to electrical. So as you are going to sit for that exam, make sure you remember this. You remember this. Yeah, you remember this. We have the next question, and the next question is density. Of course, we've worked out the concept of density, and I would like you to write in the chat section how we can be able to work out that. Of course, we say that mass is equals to 120 grams, volume in this case is given as 16.0 centimeter cubic. Then you can be able to say density is equals to mass over volume. Now, to work out this, we are going to use the formula here, and since we are working out the units for density are going to be in grams per centimeter cubic, so we shall stick to that. So we shall say this is 120 divided by 16. If you work it out, 120 divided by 16, which is going to translate to 7.5. grams per centimeter cubic. 7.5. 7.5. So another area. Now the diagram shows load extension graphs. So this is the topic that you look at, is called Hooke's law. Yeah, so you shall be doing the topic Hooke's law, and I believe you'll be in a position to understand what it involves. So what you need to remember here is how Hooke's law states. Hooke's law states that extension is directly proportional to the force applied, provided the elastic limit is not exceeded. And the steeper the line, it means it has a larger spring constant. A less steep is as a lower spring constant, because the gradient represents the spring constant. Now, determine the extension of spring A for the load of 10 newtons. So you're going to check, where do we have 10 newtons? Here. Then you're going to go across and draw a line and check where that is going to meet the graph of A, spring A, and then draw another line, read the value that you have at this point, right? So basically that's what you're going to do there. So which means if you are having 10 small boxes, this means one small box is 1 unit each case, 1 unit each case. So that is going to be 10, 11, 12, 13. So we are going to say this is 13 millimeters. That is the extension. Extension means how much the string stretches. How much does the string extend? Which spring is easier to stretch? Which spring is easier to stretch? So in this case, you are looking at the gradient of the graphs that we are having at this point. Yeah. So in this particular part, we are going to say the spring that is easier to stretch is B, spring B. Yeah, and the reason, same load gives a greater state which spring is easier to stretch. So we are going to say it's B. Now look at the load. Yeah, look at the load of 10 newtons. It has given an extension of, an extension of 13 centimeters. But if we were to extend that and we check here, you'll see this force that is this load that is acting at that. If we were to check for B, it will be in front here. Yeah, to be in front here, which means this is going to be 10, 11, 12, 13, 14, 15, 16, 17. This will be a whole of 17. So for B, it will be 17 millimeters. So that's why you can see now B is easier to stretch, because same load gives a greater extension. It gives a greater extension than spring A. You see, spring A will give you extension of 13, but B will give you a beautiful extension of what? 17. So it's easier to stretch spring B than A. So basically that's what we were to say at that particular point. Now in this topic also, you need to remember that force is equals to Kx, where this is the force or load applied, this is spring constant, and at this point here, this is extension. So this is the concept that you need to remember as far as this topic of Hooke's law is concerned. So these are the areas that you're gonna be tested, the areas that you're gonna be looking at later. So we shall be having series of different topics, different concepts that you have to remember in order to sit for this particular exam. Describe how geothermal power station generate electricity. So you can say as water and in that we are focusing on as water in form of steam exit, it has high kinetic energy, which turns the turbines, and as the turbine turns, it rotates the generator. As the turbine turns, this rotates the generator, which produces electricity through electromagnetic induction. So basically that is how electricity is generated. Under thermal energy, at the beginning you learn how to convert degrees Celsius to Kelvin. This you shall add 273. So in that case, we're going to say this is -10 plus 273, which is going to turn 263 Kelvin as the answer in that case. You need to understand as the bottle becomes warmer, what happens? We are going to say pressure increases. Explain why the pressure of air in the bottle changes. So we are going to say as temperature increases, kinetic energy of the air molecules increases. This results to more collision per unit area, increasing force exerted. on the wall. But you have to remember that pressure equals to what? Force over area. So if there is a larger force exerted on the wall, it will mean there will be a larger pressure exerted. State and explain how this changes temperature. Evaporation. How does evaporation cause cooling? A beaker contains water. Some water evaporates. Evaporation changes the temperature of water that remains in the beaker. So as water evaporates, what happens? More energetic water molecules escapes, leaving behind molecules of less kinetic energy. So this is going to leave behind molecules of less kinetic energy. Thus, temperature of water decreases. Yeah, so whenever evaporation takes place, it means molecules which have high kinetic energy are going to escape from the water surface, and the molecules that are left behind are molecules which have less kinetic energy. When a substance has high kinetic energy, it means the temperature is high. Yeah, so because if you're increasing temperature, you are increasing the kinetic energy. So meaning if you have less kinetic energy in the water content, the temperature of that water is going to be less. Looking at question number 6, calculate the new volume. In this case, we are going to use the formula P1 V1 is equals to P2 V2. We know that pressure and volume are inversely proportional. So if volume increases, pressure decreases. Now we are told that the gas cylinder is having this volume and the pressure inside there is that. So we can be able to say 0.9 times 10 raised to power 5 times 3,400 should be equal pressure to, which is 2.5 times what? Times 10 power 5 times V. So which means that V is going to be 0.9 times 10 raised to power 5 times 3,400 divided by 2.5 times 10 raised to power 5. So we can be able to put that in the calculator in the process of working it out. 0.9 times 10 raised to power 5 times 3,400, 2.5 times 10 raised to power 5. Also, for this case here, if you work it out, you're going to get 1224 centimeter cubic as the answer in that case. Now the gas in the cylinder is now heated. The piston remains fixed in the same position. State and explain in terms of why any change of pressure. State and explain in terms of molecules any change in the pressure of the gas. Temperature in this case is what? The piston remains the same position. Temperature is increased. Temperature is increased. Now, what is going to be the effect in terms of this? Any change in pressure? How is this heating if the temperature is going to be increased? volume remains constant. How is this going to affect the pressure inside the molecules that are here? So what we understand is that these molecules that we have inside this particular cylinder, they are always in a continuous random motion. So they move randomly. As they move randomly, they are going to collide with the walls of this cylinder here. So in the process, they are going to exert a force, and when force is exerted, is going to result, when force is exerted per unit area, is going to cause to an increase in pressure. So when temperature increases, kinetic energy of the gas molecules is going to increase. Yeah, so meaning these particles are going to collide more frequently with the walls of this particular cylinder. So how is that going to affect pressure? Pressure, we are going to say pressure increases. In this case, pressure increases. So if pressure, what is the reason as to why pressure increases in this case? Why is pressure increasing? If you are asked, what are you going to say? Pressure increases. Why? Why? What are you going to tell the examiner? So we are going to say, as temperature increases, kinetic energy of the molecules will also increase. Hence, more collision per unit area, thus pressure increases. Pressure increases. Thus pressure increases. So basically, that's what we are going to say in that part. And we have another question that says, in a game, we are told here that in a game of tennis, a player hits a stationary ball with a racket, with his racket. The racket is in contact with the ball 6.0 milliseconds. 6.0 milliseconds. And the force is this. Calculate the impulse. We know impulse is equal to force times time. So which means in this question, you will write 400 newtons times time in second. This will be times 10 raised to negative 3. Because it's milliseconds, you have to convert it to seconds. So that is going to be 6 times 10 raised to power negative 3. Milli, if you want to convert milli to milli means times 10 raised to negative 3. So you can take this value times 10 raised to negative 3 or divide by 1000. You'll have corrected that. So you can be able to do the calculation. So that will be 400 times 6 times 10 raised to power negative 3. And the answer becomes 2.4 Newton second, NS. 2.4 NS as the final answer in that case. Yeah. And something that you need to put into consideration is that impulse is equal to the change in momentum. The mass of the ball is this. Calculate the speed in which the ball leaves the racket. Yeah. Speed at which the ball leaves the racket. So what are we going to do in that particular case? We've worked out that we have worked out the impulse which we have gotten, it will be 2.4, and we need also to say that impulse is equals to change. Okay, let me use words, change in momentum, which is Ft is equals to mv minus mu. Yeah, but initially the ball will be at rest, will rest on the rackets instantaneously. Yeah, the ball will rest on the racket instantaneously before leaving at a particular speed. So which means the initial velocity u will be equals to 0 in that case. So which means that 2.4 will be mass, which is 0.056 times v minus 0, because now in that case it will be initially when the racket hits, sorry, when the ball hits the racket, when the tennis ball hits the racket, it will go to momentarily at rest. It will be at rest momentarily, then it moves. So which means we shall have 0.056 v is equals to 2.4 divided by 0.056 divided by 0.056. This will cancel out. V will be equals to what? 0.056, and the answer becomes 43 meter per second as our final answer in this particular case. So basically that's what we were supposed to do in that case. And also you need to understand the formula. Complete by writing the quantity mass times acceleration. Actually this is force times time, that is impulse. Yeah, so these are some of the concepts that you will really need to know as far as IGCSE Physics 2026 is concerned. See you guys. See you in the next tutorial. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. Also guys, remember to check in our Patreon page. You can be able to access different materials there which can enable you to accelerate your revision program. See you in the next tutorial.